Hello students, welcome back to KHC Online Education. Based on what you have learned in your previous classes, I want you to solve these questions first and you can verify your answers as well. Okay, now today we are going to discuss multiplication of higher order numbers. Okay, so higher order numbers are numbers in 4 digits, 5 digits, 6 digits, which are not of our regular use normally, right? So, but still, we are going to look at the steps involved in multiplying these numbers, all right? So, first of all, we are going to see the steps involved in multiplying 4-digit number, okay? So, for 4-digit number, you know, the first thing is to multiply vertically the ones digit. After that, you cross multiply the tens digit with the ones digit and add it up, right? The third is to multiply hundreds digit with ones digit and vertically multiply tens digit and their sum. Now, here is the fourth step, which was unique just for 4-digit number, all right? Like you've never seen this before in any of the previous steps, right? So here is the fourth step, which is to cross multiply thousands digit with ones digit and cross multiply hundreds digit with tens digit and find out their sum. Okay, so this is multiplied and the last two are multiplied and their sum is found out. That is the fourth step. The fifth step is to cross multiply thousands digit with tens digit and vertically multiply hundreds digit. That is your fifth step. The sixth step is to cross multiply thousands digit with hundreds digit and find out their sum. And final step is to vertically multiply the thousands digit. Okay. So these are the steps involved in multiplying 4-digit numbers. Let us look at one example. So first thing, you vertically multiply the units digit. So the answer is 8. Next, you cross multiply and 0 times 2 is 0 and 7 times 4 is 28. So you write 8 and you carry 2. So you're carrying over 2. Okay. Next, you cross multiply 1 with 2. The answer is 2. 4 with 0. The answer is 0, 0. Okay. So the answer is 2. But you are carrying over 2. So you write down 4. Next, you cross multiply the end digits. So 2 times 2 is 4, 3 times 4 is 12, 7 times 1 is 7 and 0. When you add it up, you get 11 plus 12 which is equal to 23. You write 3 and you carry over 2. Next, you're still carrying over 2. Don't forget that. Next, you cross multiply the first 3 digits, okay, and vertically multiply the hundreds digit out here. So you get 7 times 2 is 14 and here you get 0 0 and you're still carrying 2, so you write 16. Instead of 16 you write 6 and you carry 1. Now you cross multiply 2 with 0, the answer is 0. 3 times 1 is 3, you're carrying 1, so you write down 4. Finally, the last step is to vertically multiply the thousands digit. That's 3 times 2 which is equal to 6. Write down. And that's your final answer. Okay, that's a complete answer. So this is the product of the given two numbers. All right. Now we are already familiar with the multiplication of 2-digit, 3-digit and 4-digit numbers. But how do you multiply numbers with an unequal number of digits? Yes. So for example, if you're supposed to multiply 65 times 235, right? So in this case, the number of digits is not equal. So what are you supposed to do in that cases? All right. So we are going to see that. Let us suppose you want to multiply 342 with 2009. One of the number contains 3 digits and the other one contains 4 digits, right? So now for such a multiplication, which technique will you use? Will you use the technique used for multiplying numbers of 3 digits or the technique used for multiplying number of 4 digits? You don't know. You're confused, isn't it? To multiply 342 with 2009, we just express this smaller digit number as a 4-digit number by inserting zeros. Okay, so by inserting zeros, we can get equal number of digits in both the numbers. So now use the technique for 4-digit numbers. Now as you see that both of your numbers have 4 digits, so you can use the 4-digit number multiplying rule. So here you can just do your calculations now. I'm sure you can do it yourself and find out the answer. Okay. Now let us look at the characteristics of crisscross multiplication. So, to understand the characteristics, we shall carefully observe the steps used in multiplying 2-digit, 3-digit, and 4-digit numbers. Okay. Now for 2-digit multiplication, the steps involved were 1, 2, and 3. Right? I hope now you're familiar with the notations. For 3-digit multiplication, the steps involved were 1, 2, 3, 4, 5th. For 4-digit multiplication, 1, 2, 3, 4, 5, 6, 7. Okay. So what did you see? Okay. Carefully look at them and then now you'll understand the properties of crisscross multiplication. The number of steps used for multiplying 2-digit, 3-digit, and 4-digit number is 3, 5, and 7. If you go back to the steps, you'll see that for 3-digit multiplication, the steps involved are 5, right? For 4-digit multiplication, the steps involved here are 7, isn't it? So similarly for 2-digit multiplication, you see that the steps involved are 3 in numbers. The number of steps used for any multiplication can be found using the formula 2 multiplied by number of digits minus 1. So this is the formula which we can use to find out the number of steps involved. Okay, how is it? When we multiply 2-digit numbers, the steps used are, the formula is 2 multiplied by number of digits. So in a 2-digit number of digits is 2. So 2 into 2 is 4 minus 1 is 3. So that is why we have 3 steps in 2-digit multiplication. Whenever we multiply 4-digit numbers, the steps used are, again the formula 2 multiplied by number of digits. So for 4-digit numbers, number of digits is 4. 2 times 4 is 8. Minus 1 is 7. So therefore 7 steps are involved in 4-digit multiplication. Similarly, to find out the number of steps involved in 5-digit numbers or in 5-digit multiplication, the number of steps can be found out by using the formula again. So it's 2 times 5 because 5 is the number of digits. That is 10. 10 minus 1 is 9. So you'll have 9 steps involved in 5-digit multiplication. Now, let us look at the second characteristics of crisscross system of multiplication. So the second characteristics is number of steps used will always be an odd number. Like you saw, for 2-digit multiplication, the number of steps is 3. For 3-digit multiplication, the number of steps involved is 5. And for 4-digit multiplication, the number of steps involved were 7. So you always see that number of steps involved is always odd in number. Okay. Amongst these, the odd number of steps, the first and the last steps are mirror images of one another. The second and the second to last steps are mirror images of one another, and so on. Now, what do they mean by that? We'll look at one of the technique. Okay. Like if you see for 4-digit multiplication, you see that the first technique and second technique, or the last technique, sorry, the first and the last technique are exact similar. They are mirror images. This one goes to the first, this one goes to the last, right? The second and the second last, They are identical, right? Crisscross, crisscross of 2 digits. The third and the fifth, okay, the third and the fifth step, they are again identical. Three numbers involved, right? And you see that the fourth or middlemost step is always unique. Okay, you see, it's the unique, or the central step does not have any mirror image. So that is the third property now. All right, look at this. In every case there will be a central step which is independent, that is, it doesn't have any corresponding mirror image. So I hope you're clear with the mirror images out here. Okay. Again, out here the same thing has been discussed. Okay, step 1 and step 3 are mirror images. Step 2 is the central figure. In 3-digit multiplication, step 1 and step 5 are mirror images, 2 and 4 are mirror images, but 3 is the central figure. Okay, now we'll quickly look at the steps involved in 5-digit numbers. First, you multiply one's digit, then crisscross 2 digits, 3 digits at a time, 4 digits at a time, 5 digits at a time. Okay, now you see this is the unique most, isn't it? Now in sixth step, 4 digits are involved, like in case of fourth step, right? Again, you see this is the mirror image, right? This one is the mirror image of second one, and the last one is the mirror image of first one. Similarly, you can look at the techniques involved in 6-digit numbers. Ones digit, ones and tens, ones tens 100, ones tens 100,000, up to 10,000, up to lakh, right? Isn't it? So this is the centralmost step now. Okay, 7th step, 8th, 9th, 10th, 11th. So steps involved in 6-digit number is given by the formula 2n minus 1. So 2 into 6 minus 1, that's 12 minus 1, which is equal to 11. So you see that 11 steps are involved in this technique. We can look at this technique involved in multiplying 7-digit numbers as well. Now I'm sure you're familiar with this notations. It isn't completed yet. So this is how the central image becomes the most unique one, and the other ones are just the mirror images of corresponding position, right? So here is a small exercise based on what you have learned till now. Okay, it's all about multiplying numbers only. I've given you the answers as well, so you can just solve them and verify your answers. All right, so today's fun fact is 2 and 5 are only the prime numbers that end with 2 and 5. No other number that ends with 2 or 5 is a prime number, because if it ends with 2 or 5, then it is divisible by 2 and 5 respectively. So therefore 2 and 5 are the only prime numbers that end with 2 and 5. That's a cool fact, I think. That's it for today's class. I'll see you in the next class with a new technique. Till then, keep practicing. Bye.